Welcome students. In this lecture, we are going to see the intermediate code variants. Before we start IC variants, I'll tell you where the IC is generated. As we have seen analysis phase, as we have seen pass 1 of the assembler. So at pass 1 and at analysis phase, there is something intermediately generated called as intermediate representation. We say it as IR. In the previous videos, we have seen that IR is nothing but the contents like symbol table, opcode table, literal table, pool table, and IC. Out of which we have seen what is meant by symbol table, how it is generated. We have seen. At the same time, in the same video, we have seen how literal table is generated and how pool table is generated. So all the tables are already generated. Now only one part of IR is remaining, that is nothing but IC. So IC is nothing but intermediate code. So intermediate code can be generated in two different ways. That is nothing but two different variants, variant 1 and variant 2. So I, Professor Devi Kosti, welcome you for this lecture. Let us see variant 1. So this is IC variant 1. So now it is very easy. Don't worry about the output. So this is what assembly code and equivalent IC generated here. So this is IC. We say it as IC variant 1. So start 200. Now here, the start is represented in intermediate code as the type of start. What is the type of start? There are three types of statement. One is assembler directive. Second one is declarative statement. And third is imperative statement. So we know that start is nothing but assembler directive, AD. So from here we are going to decide what is the type of statement of start. So this we can take it from the OP tab, output table. So AD01 stands for start. 01 is the first assembler directive, that is start. End is 02. So AD02, AD, 02 stands for end. Okay. So next is 200. After start, we know that it is obviously a constant because LC is initialized with this address. So type of the operand. So operand can be C, yes, or L. What is meant by C? C means constant. What is meant by S? S means symbol. What is meant by L? L means literal. So for time being, for this particular line, start 200, we have intermediate code as AD, 01, C, 200. Second instruction is read A. So we know read is an imperative statement and which is having opcode as 09. So IS, 09 is nothing but read. This is intermediate code, and A is nothing but symbol. A is nothing but symbol, which is encountered first time in this particular program and loaded in the symbol table at first location. So S, 01. Next is loop move r a raised to comma a. So for this loop, nothing is generated, but this loop, the symbol is put into the symbol table by the pass 1. But intermediate code is generated for the rest of the part. Move r is imperative statement whose opcode is 04. A register is the first register, that's why 1. And A is symbol, that's why S, 0. Now how come this 1? So we have 4 registers, A register, B register, C register, D register. So for A raised to 1, B raised to 2, C raised to 3, D raised to 4. Next is sub. Sub is imperative statement, comma 2 into bracket. A register means 1. This equal to 1 is found first time here in this particular code. That's why L, 01. So literal which is found at first location, literal which is located at first position into the literal table is L, 01. Next is BC, GT. BC is nothing but branch on condition. GT means greater than. So we have less than equal to, greater than equal to, and greater than. So depending on that, greater than is located at fourth comparative statement. That's why 4. into bracket loop. So loop is encountered second time because A is encountered first time, loop is encountered second time. That's why loop is nothing but S, 0. Stop IS00. A DS1 for A already symbol is entered into the symbol table which was found here. This A DS1 will generate the IC as DL. Declarative statement 02 stands for DS, 01 stands for DC. Now here storage means here the constant will come. That's why C, 01. LTORG. LTORG is nothing but literal origin, which is again a similar declarative statement at 505. So DL 1, 2, 3, 4, 5 we have. I hope you got this particular example of this assembly language program converted into IC. So this is called as IC variant 1, means everything is processed in IC variant 1. So IC variant 2 is very easy. Let us go to the IC variant 2. In this IC variant, everything is same except symbol is not processed, register is not processed, symbol is not processed. Nothing is, only constants, literals are processed. A register, this greater than, then these symbols are just kept as it is. So this is IC variant 2. I hope you got this. Concluding remarks, thus we have seen IC variant 1 and IC variant 2. Slide credit goes to Professor D.M. Damdare. I hope you understood. You can see the video again. You can change the assembly code and try to generate IC for your self-designed assembly language, assembly program. Thank you. We'll stop here.